SpaceX just dropped a manufacturing bombshell that left Russia speechless. While Elon launched 132 rockets in 2024, Russia's Falcon 9 killer, still just computer graphics after 5 years and $880 million spent. Remember when Russia said Americans would need broomsticks to reach space? Those broomsticks are now dominating while Russia's copycat dream crashes. But what did SpaceX do that shocked them so badly? Let's dive right in. Here's exactly what happened that left Russia scrambling. When Elon Musk unveiled SpaceX's Raptor 3 engine, Russian engineers couldn't believe their eyes. This wasn't just another rocket engine. It looked like someone had stripped away half the components. While Russia was still stuck building their Falcon 9 killer with traditional methods, SpaceX had revolutionized manufacturing itself. The Raptor 3 engine tells the real story. Where previous versions looked like flying spaghetti monsters with cables and pipes everywhere, Raptor 3 appeared almost naked. Sleek, integrated, impossible. Russia's engineers had spent 5 years trying to copy SpaceX's old technology, while SpaceX was already 3 generations ahead. Back in 2020, Russia announced their Amur SPG project with massive confidence. Dmitry Rogozin declared they wouldn't just copy SpaceX, they'd surpass them. The budget? 70 billion rubles, roughly $880 million. The timeline? First flight by 2026. But here's what Russia fundamentally misunderstood. They thought they were competing against SpaceX's rockets. They were actually up against SpaceX's manufacturing revolution. While Russia designed their rocket the traditional way, handcrafting components, assembling piece by piece, testing for years, SpaceX was perfecting something unprecedented. They weren't just building rockets anymore. They were mass-producing them like cars. The numbers became brutal. SpaceX launched 61 times in 2022, then 91 in 2023, then 132 in 2024. That's more launches in 1 year than Russia managed in the previous decade. But what shocked Russia most wasn't the launch frequency. It was how SpaceX kept making their rockets better, faster, cheaper. Here's where SpaceX's manufacturing genius became clear. The original Raptor engine had 185 tons of thrust and weighed over 2,000 kilograms. By Raptor 2, they'd boosted thrust to 230 tons while cutting weight by 400 kilograms. Then came Raptor 3 and everything changed. This engine produces 280 tons of thrust. That's 50% more power than the original. But weight? It actually got lighter. How is that even possible? The answer lies in SpaceX's revolutionary approach. The best part is no part. While Russia was trying to improve individual components, SpaceX was eliminating them entirely. They used advanced 3D printing to integrate multiple parts into single units. Cables, pipes, sensors, thousands of components simply disappeared into streamlined assemblies. Russia's engineers were still thinking like traditional aerospace companies. SpaceX was thinking like a tech startup that happened to build rockets. But here's the twist that really shocked Russia. SpaceX's real breakthrough wasn't the engine design. It was the manufacturing system that could produce these engines at scale. Traditional rocket manufacturers, including Russia's design bureaus, build engines like artisan craftsmen. Each engine takes months, requires specialists for every component, involves hundreds of individual assembly steps. SpaceX flipped this completely. They brought automotive manufacturing principles to space. Vertical integration meant controlling every component. Rapid iteration allowed constant improvements. Most importantly, they designed for mass production from day one. When Russia tried to copy the Falcon 9 specifications, they missed the real innovation. They focused on the rocket's appearance, while SpaceX's advantage was in how fast they could build them. Russia was trying to handcraft a copy of something SpaceX was already mass-producing. Then came the sanctions after Ukraine, and Russia hit a wall they never saw coming. The same advanced technologies SpaceX relied on, precision manufacturing equipment, specialized electronics, exotic materials, suddenly became off-limits to Russia. But SpaceX had already moved beyond these dependencies. Their vertical integration strategy meant they manufactured their own electronics, developed their own materials, controlled their entire supply chain. When Russia lost access to Western technology, SpaceX was innovating beyond it. The Raptor 3 engine perfectly demonstrates this gap. It uses what Musk calls the most advanced 3D metal printing technology in the world. Components that would take Russia months to manufacture and assemble, SpaceX prints as single integrated units in days. This isn't just about speed, it's about capability. Russia's manufacturing methods simply cannot produce what SpaceX routinely builds. The technology gap has become unbridgeable. Let's look at what SpaceX achieved with their manufacturing revolution. The Raptor 3 engine weighs 3,360 pounds, but produces 560,000 pounds of thrust. That's a thrust-to-weight ratio that seemed impossible just years ago. Meanwhile, Russia's promised Amur SPG engine still doesn't exist outside computer simulations. 5 years and $880 million later, they haven't built a single test engine, let alone achieve the manufacturing capabilities needed for mass production. SpaceX's Starbase facility can now produce multiple rocket engines per week. Russia's entire space industry struggles to complete one major project per year. The manufacturing revolution that started with simple improvements to the Merlin engine has become an insurmountable technological advantage. By 2024, something telling happened. Russian media stopped showing new Amur SPG footage. The same computer animations from 2020 kept recycling on state television. No hardware updates, no test firings, no progress reports, just the same digital promises. Industry experts began asking uncomfortable questions. Was this even a real project anymore, or just sophisticated propaganda? The pattern looked exactly like Soviet-era space announcements. Beautiful artwork, grand promises, but no actual deliveries. Eric Berger captured it perfectly. 13 years after SpaceX's Grasshopper first demonstrated reusable rocket technology, all Russia has are renderings. But the biggest shock to Russia wasn't just SpaceX's manufacturing speed. It was the realization that SpaceX had fundamentally redefined what a space company could be. While Russia remained trapped in Cold War thinking about prestige projects and government funding, SpaceX proved space could be about rapid innovation, commercial efficiency, and exponential scaling. Russia's space program, built on Soviet-era design philosophy, had no framework for this kind of transformation. Their manufacturing methods, optimized for single-use systems and decades-long development cycles, couldn't adapt to SpaceX's iterative approach. When Elon Musk responded to Russia's Amur SPG announcement, his advice revealed the gap. They should really aim for full reusability by 2026. Goals should be to minimize cost per useful ton to orbit. SpaceX wasn't just building better rockets. They'd reimagined the entire industry. Today, SpaceX's manufacturing capabilities continue accelerating. They're not just building Raptor engines, they're preparing for Raptor 4, 5, and beyond. Each iteration removes more parts, increases performance, reduces costs. Russia's timeline keeps slipping. Originally promising 2026, then 2028, now maybe 2030 for their first Amur SPG flight. Meanwhile, SpaceX has moved on to Starship, a rocket that makes their own Falcon 9 look small. The manufacturing revolution that shocked Russia in 2022 has become an unstoppable force. While Russia struggles to move from PowerPoint to prototype, SpaceX is planning Mars colonies with rockets they're already testing. What started as Russia's confident promise to surpass SpaceX became a masterclass in how manufacturing innovation beats traditional aerospace thinking. The shock wasn't just that SpaceX built better rockets. It's that they proved the entire industry had been thinking too small. So here's what Russia's shock really tells us about the future of space. This isn't just about rockets anymore. It's about which countries and companies can adapt to exponential technological change. While Russia spent 5 years and $880 million chasing yesterday's technology, SpaceX revolutionized manufacturing itself. The manufacturing breakthrough that stunned Russia is already spreading beyond space. The same 3D printing, vertical integration, and rapid iteration principles are transforming industries from cars to construction. We're witnessing the birth of a new industrial revolution, and space is just the beginning. But here's the bigger question. If SpaceX can do this to rocket manufacturing, what happens when they turn these same principles toward Mars habitats, space stations, or technologies we haven't even imagined yet? The shock Russia felt in 2022 might be nothing compared to what's coming. What do you think will be the next industry to get the SpaceX treatment? Let me know in the comments below, and don't forget to subscribe for more deep dives into the technologies reshaping our world. The future is being written right now, and you won't want to miss what comes next. SpaceX builds 300 plus engines while Blue Origin makes just dozens? That's right. The production gap is absolutely shocking. While Elon Musk's team cranks out one Raptor engine every single day, Blue Origin celebrates building dozens per year from their massive factories. But here's the real kicker. Each SpaceX engine costs $500,000 versus Blue Origin's $8 million each. So how is this insane difference possible? Let's dive right in. Here's where this story gets absolutely insane. While the entire aerospace world was focused on who could reach orbit first, SpaceX was quietly building something that would change everything. A rocket engine assembly line that produces more engines in a single month than most companies build in their entire existence. Picture this. At SpaceX's McGregor facility in Texas, every single day at exactly the same time, a brand new Raptor engine rolls off the production line. Not every week, not every month, every single day. By late 2022, they hit the impossible milestone, 365 complete rocket engines per year from one facility. That's one engine every 24 hours, including weekends and holidays. The numbers are so staggering that when industry experts first heard them, many thought it was a typo. But here's where it gets even crazier. They've actually slowed down production recently. Why? Because they're focusing on quality improvements for their next generation Raptor 3 engines. Even at this reduced pace, they're still manufacturing around 300 engines annually. Meanwhile, Blue Origin, with their massive 600,000 square foot facilities spanning Washington and Alabama, celebrates building dozens of engines per year. Let that sink in. Dozens versus hundreds. But the real shock comes when you see the price difference. This is where Blue Origin's strategy completely falls apart. Each SpaceX Raptor engine costs approximately $500,000 to build. Each Blue Origin BE-4 engine, a jaw-dropping $8 million? That's not a mistake. We're talking about a 16 times price difference for engines that do essentially the same job. But how is this possible? SpaceX revolutionized everything by treating rocket engines like cars rolling off an assembly line. They embraced 3D printing technology, automated manufacturing, and mass production techniques borrowed from the automotive industry. Every process was optimized for speed and scale. Blue Origin stuck with traditional aerospace manufacturing, small batches, extensive hand assembly, and artisanal craftsmanship. Each engine is essentially handcrafted like a luxury watch, which sounds impressive until you realize it makes space exploration prohibitively expensive. This cost difference isn't just about bragging rights. It fundamentally reshapes what's possible in space. SpaceX can launch their massive Starship for just $2 to $3 million per flight. Blue Origin's New Glenn? The engine costs alone make this price point impossible. But there's something even more shocking about how these companies ended up in such different places. While the public watched legal battles and press releases, a secret manufacturing war was raging behind closed doors. This wasn't just about who could build better engines. It was about who understood the future of space exploration. Blue Origin's approach seemed logical. Hire the best engineers, build the most sophisticated facilities, and create the most advanced engines possible. They massively expanded their Huntsville facility, installed cutting-edge equipment, and hired hundreds of specialists. But SpaceX was playing a completely different game. While Blue Origin was perfecting individual engines, SpaceX was perfecting the system that builds engines. They weren't just making better rockets. They were making better rocket factories. The breakthrough came when SpaceX realized something revolutionary. The bottleneck in space exploration isn't technology, it's manufacturing. You can design the perfect engine, but if you can only build a few per year, you'll never make space accessible to everyone. This philosophy led to a radical decision that shocked the aerospace industry. SpaceX implemented what Elon Musk calls the algorithm, a manufacturing philosophy that questions every component, every process, every assumption. The first rule: the best part is no part. The best process is no process. This led to the revolutionary Raptor 3 engine, which looks like someone stripped away half the components from previous versions. Industry experts initially thought the first photos were fake. Surely this couldn't be a complete engine. But it was. By integrating multiple components into single pieces using advanced 3D printing, SpaceX eliminated thousands of potential failure points. Each Raptor 3 weighs 170 pounds less than Raptor 2, while producing 100,000 pounds more thrust. The visual difference is staggering. Raptor 1 looked like what engineers call flying spaghetti monster, a maze of cables, sensors, and external components. Raptor 3 looks almost skeletal, with clean lines and integrated systems. Blue Origin's BE-4 still uses the traditional approach: thousands of individual components, external wiring, and complex assembly processes. It works, but it's fundamentally limited by its complexity. But there's an even bigger twist coming that nobody saw. Here's where Musk's vision becomes truly audacious. SpaceX's long-term goal isn't just to build more engines. It's to build 1,000 Starship rockets every year. Do the math. Each Starship needs about 39 Raptor engines, 33 for the booster, 6 for the upper stage. That means SpaceX will need to produce 39,000 engines annually, more than 100 engines every single day. This isn't science fiction. SpaceX is systematically building the infrastructure to make this reality. Their current 300 engines per year is just the beginning. When Raptor 3 reaches full production, they expect 400-plus engines annually from existing facilities. But they're not stopping there. New production facilities are planned, manufacturing processes are being automated, and supply chains are being optimized for unprecedented scale. Meanwhile, Blue Origin celebrates producing dozens of engines per year from facilities larger than SpaceX's entire operation. But raw numbers only tell part of the story. The technology gap between these engines is equally staggering, and it reveals why SpaceX's approach is fundamentally superior. Both engines use liquid methane and liquid oxygen.